Today, a large part of the sawn timber produced worldwide is technically dried. A drying adapted to the later application reduces undesired dimensional changes. Lumber drying can be carried out with good or less good results. That's why we want to focus today on controlling the drying quality. What does quality actually mean? There is no absolute standard for quality. Quality is understood to be the degree of suitability for a specific purpose. You could also say, if the customer is satisfied, then the quality is okay. It is obvious that different quality requirements are set when drying wood for parquet or high-quality furniture than when drying wood for packaging purposes. The main purpose of drying is to reduce wood moisture. The target humidity is a central criterion. In a drying batch, there will always be differences in humidity between the boards. The mean value of a sample should be as close as possible to the target moisture content. The extent of the permissible differences between the boards depends on the intended use. How do we determine the wood moisture? The drying process is monitored by 3 to 8 measuring electrodes distributed in the dryer charge. After the drying process is completed, the results are usually checked by randomly measuring individual boards in the stacks. For the sake of simplicity, the electrodes are often hammered in from the side. Modern sawmills measure every single piece with so-called inline wood moisture meters during the sorting process. This gives a very precise picture of the moisture distribution in a batch. Boards with too high moisture content are marked and sorted out. The customer should always check the drying quality immediately upon acceptance as part of an incoming inspection. When checking the drying quality, other quality features are checked in addition to the wood moisture. Drying stresses are made visible by the fork sample. A crossbar is cut parallel to the surface in the form of a fork. The deformation of the fork prongs shows the state of tension in the board. Alternatively, the center cut method according to CEN TS 14464 can be applied. Surface cracks appear at the beginning of the drying process, which can also close again during the drying process due to the stress reversal. Closed surface cracks cannot be seen with the naked eye. For this purpose, about 5 to 8 mm strips are cut from a crossbar parallel to the surface. If surface cracks are present, the strips fall apart during sawing. Internal cracks appear in the second third of drying after the stress reversal. If the tensile stresses on the inside exceed the transverse tensile strength, the resulting inner cracks are not visible from the outside. To detect internal cracks, crossbars must be taken at a distance of at least 0.3 meters from the end of the board. Cell collapse occurs in some wood species in the early stages of drying due to capillary tensile stress. Cell collapse is often associated with cracking. Internal cracks caused by collapse are usually short and stocky, lens-shaped. Stress-induced internal cracks are narrow, elongated, and usually follow the wood rays. Most deformation of sawn timber during drying is either natural or unavoidable, e.g., shrinkage and anisotropy, cupping, depending on annual ring position, and curving. The twisting of sawn timber results from the slope of grain in the boards and is due to the quality of the wood. Improper stacking and loading of the drying chamber can also lead to undesirable deformations. These deformations are not natural but are clearly due to improper drying.